All right, let's talk about geometric probability, and it's very similar to normal probability, where the probability of an event happening is P over Q, where P is the number of positive outcomes and Q is the number of total outcomes. So I mean, the simplest way to think about it is a die. A die has 6 sides. That's a side with 1, a side with 2, a side with 3, a side with 4, a side with 5, and a side with 6. So the probability of rolling a 1, the only way that I can roll a 1, there's only one way to roll a 1, and it's rolling a 1, out of 6 possible different outcomes. So the probability of rolling a 1 is a 1 out of 6. To roll an even number, there's 3 ways that I can roll an even number, a 2, a 4, or a 6, out of the possible 6 different outcomes. So the probability of rolling an even number is 3 out of 6, or 1/2. So half the time, you're going to roll an even number. So that's probability. Now, as far as geometric probability is concerned, let's talk about like a target board. If you're throwing darts, you got circles. I don't know if I can easily draw some circles. Shapes, dangerous. Cool, that worked. Yes. All right, so this is a very simple dartboard. And let's say that this has a radius of 1, and the big circle has a radius of 4. Maybe, I don't know. So the probability of getting in the bullseye would be the area of this small circle. Now the area of the small circle would be, remember, pi r squared. So pi r squared is just 1. So 1 pi. Out of the entire dartboard would be 16 pi. So simplifying that, we get 1 out of 16. So if you're throwing completely random darts that can only go in the dartboard, your probability of getting a bullseye is 1 out of 16. And really, that's it. The bullseye is the positive outcome. The full dartboard is the entire outcome. Now, we could also say, what is the probability of you not getting a bullseye? Well, not getting a bullseye is the area that's not this. Is not the bullseye. It's a pretty little flower. Now, what is this area? The area of this donut? Well, it would be the full circle minus the bullseye, which would be 16 pi minus 1 pi, which is 15 pi. Out of the full dartboard again, it's still 16 pi. So the probability that you're not going to hit the bullseye is 15 out of 16. Now, a cool thing about probability is that every possible outcome should add together to be the full set of outcomes. So in this case, you can either hit the bullseye or you can not hit the bullseye. There's 2 different ways that this can happen. Now, 100% of the time, you should hit the dartboard. But the dartboard is combined of the bullseye and not bullseye. So I should, 1/16 plus 15/16 should give me anywhere on the dartboard. And it does, 16/16. So 100% of the time, I'm going to hit the full dartboard. 1/16 of the time, I'm going to hit the bullseye. 15/16 of the time, I'm not going to hit the bullseye. That's geometric probability. It's just taking, instead of saying like the number of sides on a die, you're looking at different areas. And that's really all it is. It's pretty cool.